Hi, welcome to a teardown and potential repair, I hope, of this Fluke 169 Scopemeter, kindly sent in by Ronald Bryant to the mailbag. Thank you very much, Ronald. It's a classic two-channel isolated scope meter, 100 megahertz, 1 gig sample per second. We've got a problem with the screen on it, so let's rip it apart and see if we can fix this puppy. Now, it doesn't actually come with the battery, and it's got one of those super duper recessed DC power jacks in it. So unless you've got the correct type of power jack, the one I've got just doesn't fit in there. You've got to have one of those special deep ones. But thankfully, we can just take those two screws off there, and we can get in like Flynn, no worries. And it's got one of these evil center negative power jacks on it, so instead of the usual center positive, so trap for young players. Anyway, I powered it up 17.5 volts on the external DC power jack. We don't have the internal battery, we don't need it, and you can see here is the fault, and we've got all these dark horizontal lines right across, but you can see all the text is just fine. The vertical graticules, look, auto, everything's working just hunky-dory. So there's something just wrong with those lines there. Now, this can be one of a couple of things. Now, the first problem could be mechanical due to the connections, however they connect this LCD in there by, zebra strips or however it's connected in there. It could be hot bar attachment or whatever. We don't know until we get in there, tear down and take a look. And just like in science with Occam's razor, I'm going to put forward Dave's razor, where if you've got a fault and you're not sure whether it's, equally likely to be mechanical or electrical, go for mechanical. And of course, it could actually be electrical. It could be some sort of, horizontal driver chip or something like that. We don't know how this thing's driven, whether it has a controller built into the LCD itself, whether or not it's built into the processor and chipset driving this thing. It's got a separate graphics chip. We're not sure until we do the teardown. And there's actually a third option, which is the least likely, in that it could be some video memory mapping issue, i.e. a fault with the video memory. And this was, not an uncommon fault for really old gear that used a processor and then separate memory, and then it'd probably have separate video memory chip, for example. It could be something wrong with the separate video memory chip, but incredibly unlikely, almost to the point of not even considering it, because the video memory in something like this would be, inside the processor itself, and everything's fine with the text and it's incredibly unlikely, but I thought I'd mention it. So the first thing we want to do is a bit of percussive maintenance here. And that's a classic engineering term, percussive maintenance. I'm trying to put some flex on this, but geez, this is pretty tough, these Fluke scope meters. They're built like a brick dunny, and yeah, I don't like our chances. But anyway, doesn't seem to be anything like that. And opening this puppy up's real easy. You take off the bottom boot, two screws down the bottom here, and then the whole cover lifts off. It's designed to lift off because the battery is user replaceable. The BP190 battery just sits in there. It's like a triangle arrangement. The cells arranged in a triangle shape, and there's the header connection for the custom battery in this thing, which we don't have. But we've got some shelled in there, so let's see if we can take it apart, get access to the LCD. And I'll tell you what I hate, screws that aren't magnetic. I've got one of these magnetizer, demagnetizer. Very handy if you don't have one. And we can't pick up the bloody screws. Yet I can pick up this huge, heavy bit, no problems at all, but no. And here we go, we're in like Flynn. I took off some of the shields here, and let's have a look, because this is like a teardown, let's have a look at the input amp here. Look at this. Is that, oh no. Look, what have they done there? They've tried to put some, hide it? I don't know. It's probably some Fluke custom front end would be my guess. But look at the isolation slots here. Very nice. No problems there at all. And big isolation slot here separating the multimeter section from the oscilloscope section. This will be an identical channel up on channel 2 up here. We've got a decent looking Japanese relay there. It all looks nice and neat and tidy, and we've got looks like a converter and a massive opto isolator here by the looks of it for the data transfer. So this would be the isolation for the power, so they've just got an isolated power converter there in some custom package. I got no idea what that is. VDGTN9. And here's the multimeter section. Once again, we've got some isolation slots. It's all done nice and dandy. It looks like we've got a MOV on the input there, OP97, a couple of little SO ICs, and well, that's about all she wrote, unless there's something on the bottom side. And once again, they're isolating the power across there, but I don't see any, well, presumably this one is the data, so I could be wrong about that, but that's more likely. So I don't see anything apart from that, so they must be getting the data across there as well, somehow. And there's nothing fancy happening with the chips on the multimeter section. It's all jelly bean stuff, 74HC4051s, you know, like it's all basic. Look at that though, that cap in there looks a little bit how you doing. A bit bodged in. Don't like the look of that. Got the wrong footprint or something. And no surprises for finding a Phillips part in there, because this is a Fluke Phillips Scopemeter, of course, so that'd be some sort of Phillips custom front end. Now, as far as the rest of this puppy goes, we've got ourselves a little optical isolation data port on the side there. There you go. That'd be transmit and receive there. And this is a big DC to DC converter, obviously. Not sure what that puppy is under there. I think I see a Phillips number. So let's take a look at that. And we've got ourselves a main processor up here. That looks like Motorola. And once again, we've got one of the, like, what? What is that? It's almost like a heatsink, like a thermal heatsink pad or something like that, but there's no heatsink on it. Anyway, Fluke custom chip. And a Fluke custom chip made by Motorola. It could be an off-the-shelf processor. I mean, here's our flash memory for it up here. It could just be, you know, custom branded for Fluke, because companies, almost any chip company will do that. They'll let you put your own part number. They'll silk screen the top of it, anything you want. If you order, you know, 10,000 or 100,000 of them or something, they'll put anything on there you want. And they've called it the Garfield. Or I'll call it the Garfield anyway. And there's the other Fluke custom chip. It's got IBM 0001 on there. Maybe made by IBM, perhaps. And what we've got on this side, we've got ourselves a membrane here going down. This will not be the LCD. That goes nowhere, so it's just a thing to like just hold it in place. So that is not for the LCD. Don't get excited. I believe that's just going down for the flat flex going down to the membrane keypad on the front. The LCD is under here. We can see the backlight there, and we flip it around. Ta-da! You might be able to just see some chippies under there. So we've got an old school LCD module. So almost certainly the fault is on there. 99.999% sure, I think. And you'll notice all these test pads down here. It looks like they duplicate and go into the contacts. The reason that they've got these test pads in here is so that in production, when they test this board, they can have a better nails which comes down with pogo pins onto all these, so they don't have to physically insert cables in there to actually test this thing. And that's just much quicker and more efficient during the production testing phase. And is that some fuse protection there on the battery pack? Looks like it. And there's our high voltage backlight inverter circuit there, which goes out to the cable over this side of the wall here. So we'll just take out a few more screws here, a couple of standoffs, and ta-da! We are in like Flynn, and hey, we got the bottom of the board too. There we go. There's how they're getting the data across from the multimeter. There we go. So those top two must be the data bricks, not the opto isolators. And I was wondering why the holes didn't quite line up for these shields. They don't go all the way through, so you can actually leave those metal shields in place when you take the board out. And the metalwork came off easily. This thing is very well designed, by the way. Oh, and, yep, look, we have rubber seal, O-ring seal right around the edges. Beautiful for, water ingress, and also handy for blast protection if you overload the inputs and things like that. So very nicely designed, this Fluke Phillips meter. Love it. Anyway, no surprises for finding Hitachi LCD driver chipsets on here. Hitachi practically maybe they still own the LCD driver market, I don't know. But yeah, they're one of the leaders. So let's go to the data sheet for these things. There's a little bit of active stuff happening around in here, but I don't expect a fault in one of these things, because once again, these are probably quadrants of the LCD. So I don't expect, and we're going in horizontal lines. I more expect something with, maybe you can see all the pins going out here, probably some maybe some zebra strips or some hot bar flat flex attachments going to the board. So I suspect it's more likely once again to be a mechanical thing happening, probably. I don't know if it's all over here, but anyway, we'll have a look when we pop that thing out. That's more likely than being an active fault, I think, anyway. Could be wrong. Hey, I'll tell you what, someone's had a go at this, and look at this. These are the clips. This is how they're supposed to look like, right? These are the clips that compress the LCD onto the board. So this is why I'm thinking that there's zebra strips under here. But look, you can see, it looks like somebody has twisted these back. And look, all the ones along the side here are not, they're not sort of, bent over to put force down. There's only like one top and bottom. What the hell? So what I'm going to do is apply power again and see if I can power this thing up. And hopefully we can, yep, okay. I haven't hooked up the backlight, but we've still got the lines on the, well, you probably can't see it, but we have got the lines on the screen there. So now I can hopefully go around, apply some pressure to that to see if it's a pressure problem. Oh, and the metalwork fell out holding the membrane keypad in there. There it is. So I'll put that back. Yeah, by the way, that was, of course, it was obviously the LCD cable here and the membrane cable. Okay, so let's see if we can get this puppy. Let's apply power. Hopefully it'll boot up. There we go. We've got our horizontal lines. So, haha, look, see that top bit? Look, there's some data missing. And yes, I'm careful not to touch the high voltage backlight. It's all like isolated. So this could be hard to get. Oh, I saw a line come and go there. I saw a line come and go. I swear I did. There's got to be something in this. Yeah. I might just go in there and reseat all of those tabs. Just bend them all back and see if it works. Unfortunately, not. I've bent them all physically back in place. You saw a couple of lines come and go there, but still not sure. Yeah, I saw just a line or two come and go. There's something mechanical there, but might have to take the LCD apart. And as it turns out, Fluke actually offer the complete service manual for this thing on their website. Fantastic. Why can't all manufacturers do that? It includes the full schematics as well for everything except the LCD module, which they say in the troubleshooting procedure, please connect a new LCD to see if the LCD is the problem. The LCD is not repairable. Oh, thanks for that. But check it out, I can make those lines come and go with pressure on this board. I was doing it a second ago. Trust me. Yes, yeah, there we go. There we go. I can make them come and go. You can see on the right-hand side there. I can make them come and go with pressure on that board. There we go. Ta-da! There's got to be some sort of contact issue. So we have some LCD voltage troubleshooting test points in the procedure here, but it's not going to be that. They're over here somewhere, probably on those test pads we saw before, but it's not going to be that. I reckon it's something down in here. It's something in the drive. I don't think it's any of the control signals, because as you saw, like the text and everything, the graticule, everything getting over fine, which means that almost certainly this serial interface is just fine and dandy. So our Hitachi chipset here, here's the data sheet. It's actually a 80 column driver. So of course you can use these for both the horizontal and the vertical they're using here. Obviously these ones are the horizontal. You can tell by their physical location going down here on the horizontal part of the screen to drive the lines like that. And then we've got the 3 column drivers here. So curiously, we've only got, unless there's another one on the bottom there, we've only got 3 here, you know, 3/8, a 240 by 240 resolution screen. That's what it must be. So I'm just going to try and separate the LCD part from the main PCB here, and I've bent all the clips back, so we should be able to lift that out. I'm not sure if I have to take the backlight out. I don't think so. That could be separate. So, but I'm concerned because I think these weren't, there was only like 2 or 3 of these that were clipped over, and it looks like somebody had pulled them back. So somebody had a crack at fixing this thing, and they couldn't, you know, had the same idea I do, and they couldn't fix it. I don't know. Anyway, it's worth a shot. So let's see if we can lift this off, shall we? Yes, I've turned the power off, in case you're wondering. There we go. Come on, you can do it. Pop out, pop out. There we go. Yep, zebra strips. Hang on. Aha, as I suspected, not only is there zebra strip for the vertical here, vertical drivers, they're not the problem, but look what we've got on the horizontal. Ta-da! Hotbar. There we go. I reckon that's our problem. Now it goes under different names, but hotbar is one of them. I call it hotbar because what they do is they like get literally a hot bar across here. It's like a huge big wedge soldering iron tip, and they apply pressure down in there, and it solders those into, look at those pain in the ass little individual contacts. You should be able to see them in HD here, but yeah, I reckon we've got bad contacts in there. Almost guarantee it. All right, watch the magic. If we put pressure on the vertical over here, we can start see, look, we can make the various parts of the vertical line up. Okay, so if we put pressure on the whole thing, there we go, we can get most of it. So that's the zebra strip. Zebra strip's just fine, but what we want to test is the horizontal in here. So I'll try and put most pressure on here and get my poker. Aha, look at that. I'm applying pressure down in there to those hotbar attachments. You can see them move. Look at that. There you go. What a bastard. Gotcha. Now, as you can see, there's actually 2 surfaces. One is between the flat flex and the PCB down like this, and the other is between the flat flex and the LCD glass itself. And both of those have an adhesive, conductive solder paste or whatever under them. So when the hot bar actually goes across there, it melts the adhesive and forms the solder connection as well. So I don't like my chances of redoing something like this. It's very fine pitch, but anyway, we might have a shot at it. But what I'm going to do is just apply pressure along here to, like I did it before, I was applying pressure on the PCB and we were getting some change. So it's most likely to be along there. If it's on the glass, well, that's a different thing again. I don't know that it's likely to be both. So if I go across the top of the glass like that without trying to put pressure on the, oh, maybe, but I think I'm actually putting pressure on, you saw it change in a different location, so I think I might be putting pressure on the board there. So I don't think the connections are on the glass. I think they're between the flex and the PCB. So that's the one I want to try and reheat and reflow and try and repair. Now, I've never actually repaired one of these hotbar attachments, and I've heard that they're real tricky, and, well, it's better if you have the right gear. I don't have the right gear, but what I do have is my hot air gun. I'm going to set it to maybe 240 or thereabouts, or to do it. And I found a pencil with, I should actually get one with a new rubber tip, but I'm going to actually use like a soft, I don't want to go over there with my plastic pointer and use that. I think that's going to be a bit hard. I want something a little bit softer than that. I've taped back the LCD to give me a bit of room, so I'm going to have to get in there and heat it up and maybe just roll the eraser across. Actually, what I can do is flip the end on that to get myself the good end. Why didn't I think of that before? There we go. So hopefully I can get in there with that and use that. Once it's heated up, just roll it maybe a bit, rub it across, no pun intended, and see if we can reflow this thing. But I don't like our chances. So I'm going to have a go. Here we go. I'm going to heat it up. And not all at once. Just move it back and forth. Once again, I have no feel for this because I've never done one before. So, I don't know. I don't even know if this will work. I have no idea. But, hey, it's worth a shot. It's a freebie. And, it's worth having a go. Have a go, you mug. Come on. And we don't want to try and avoid heating up the top glass one up there, so we don't want to do that. We just want the lower PCB one down here. And I have no idea, no feel for how long to leave that, because the board's got to heat up. The board has thermal mass, of course, and of course there's no thermal mass in the flat flex, so not worried about that. But maybe, whoa, there we go. Oh yeah, I'm starting to, oh yep, too much heat, yep, I'm starting to melt some of the flat flex. Oops. Yeah, I think I applied way too much heat there in the first go. Hope I haven't damaged the ribbon. Let's put it back together. I reckon 10% chance of fixing it. Okay, here we go. As I said, don't like our chances, but we'll give it a whirl. Hello? Hello? Maybe I think am I out of alignment there? But wow! Did that fix it? Completely. Wow, look at that top part. It's just a matter of, wow. Oh, silly me, still had the LCD taped back here, and you're probably screaming at me. So the the vertical wasn't lined up. So, oops. So I've put that back, and let's power it up again. There we go. Whoa, I've got one little pesky line. No. Yeah, is that the trace? I've got some vertical happening there, but wow, that's mostly fixed. Is that like a cursor line, or is that a line on the LCD that's not fixed? Oh, wow, but I got it. Wow, I'd actually be happy like that, even if that line was still through it. Awesome, winner chicken dinner. So I might just whack that back in the frame for a bit of alignment. And just in case I get it, don't forget to wipe all your grubby paw prints off the front of the glass, because that would suck. You put it back together, you're all proud of the repair, and there's your bloody big paw print right in the middle of it. No, I actually tried to reflow that connection again, and I think that line is supposed to be there, so it's probably a cursor. But look, we've got this pesky vertical line now. So that's a real bummer. I'm not sure what's going on there. Maybe there's some contamination under the zebra strip there, perhaps. So I just cleaned all the contacts along there and the zebra strip as well, and hopefully I can get that puppy working again. Let's give it another try. And just power this thing up and Push it on. No, still there. What's the deal? A couple of minutes ago, it was it was just one vertical line, wasn't it? Very thin one, just like that horizontal one there. Now it seems to be wider, so... look, looks like we've got another pesky vertical line that's come back right through there. I've actually bent a couple of the tabs back on the frame here, so it's all put in the original pressure back on there. And these are the cursors, don't worry about those. I just turned on cursor mode. I can operate the keyboard now. There we go. Oh, I think I can turn cursor mode off. There we go. So we can see a line through there, and we've still got this line, but as I said, I reheated it. Maybe it could be on the glass contact or something like that. Might require some, or maybe I just didn't get it second on the second reflow, or maybe it's just not possible to get it, but looks like maybe one that I missed originally is not showing up, but I don't know about the black vertical stripe. That's a real pain. Damn bloody Murphy, we almost had it. We almost had it. Maybe with a bit more fiddling I can do it. I think it's essentially just a vertical alignment, a position alignment in this direction. So you've just got to get it right in the sweet spot, and we should be able to get that vertical line to vanish. But we've still got that one pesky horizontal line. Oh, people are going to hate me if I don't finish this and get it 100% perfect. My apologies if I can't ahead of time. Well, I fixed the horizontal ones. Beautiful. I just did some more reflow and some more pressure on there. And it looks like they're gone, hopefully. Although maybe this one around here is still lurking along here. Perhaps. I'm not sure, but yeah. Anyway, I got rid of the middle one. And just can't quite get the vertical alignment here. It's really pesky. I got it! You bloody beauty! Look at it! It was incredibly touchy to its, horizontal position here, which gives the vertical columns here. And I had to muck around with it 10 times before I got that vertical strip to go away. So it's really, really touchy. And then you have to hold it in place and then try and put the bezel on. And wow, the alignment has to be bang on. So, but look, I think it's fixed. I think it's fixed. Let's go to the meter. Oh, look at that. But I don't like our chances of this thing staying like that. I suspect it might still develop a problem, but winner, winner, chicken dinner. Wow. I didn't put my odds very high of fixing that, but hey, had a go. Got lucky. Well, here we go. It's back together. Fingers crossed. Let's power it up. And, well, it helps if I turn the switch on. Here we go. You hear a relay click there, which is interesting. When you actually switch the thing off and on, there's a relay before you hit the soft power button. So, that's rather interesting. Oh, yes. Yes. I thought that was the line there. Oh, no, is it? Yes. Ah, there's a line showing up again. Damn it. Yep. Ah. Ah. Would you believe it? Murphy gets you every time. Damn it. Well, I'm not too fussed about that. I'm not going to take it back apart and endure that vertical alignment thing. And no, I'm going to be happy with that and call it quits. And wouldn't you believe it? Murphy again. The scope doesn't work after repairing the LCD. I can't get anything on the bloody thing. Just flat line. Oh. Although, the meter seems to work just fine. At least on ohms, anyway. Slow as a wet week on the auto ranging there, but yeah, that's bang on. And the voltage is pretty bang on too. Check it out. There's... yeah, I've checked it with another meter. That's bang on. I can't get my calibrator over here easily because I'm tethered to this bloody power supply. Anyway, yeah, the multimeter seems to work. The scope, nope, not a sausage on that scope, and I've got no idea what the problem is. Both channels, just absolutely nothing. So maybe it had multiple, looks like it had multiple faults, the LCD. Anyway, we fixed the bloody LCD winner. I'm going to call that repaired because, well, if this scope did work, it would have been repaired. Yeah, Murphy will get you with that sort of thing, but we did get a bit of bad luck in the end there with that line coming back up. As you saw, it was fine when I put it back together, and then when I screwed the whole thing on, the line came back. So, you know, yeah, if you were keen enough, you would dick around, but I wouldn't bother about that horizontal line. It's off the, you know, the main waveform window, practically right at the bottom, so I wouldn't worry about something like that. But yeah, repairing these hotbar things can be really quite tricky. So yeah, just be careful with the amount of heat you put on there, but you can actually repair them. Hot air and the end of a rubber eraser on the end of a rubber pencil seems to work a treat. Just, you know, roll it across like that. As you can see, I did a bit of wearing out there. Didn't like the heat, but yeah, just roll it across or push it across like that, and yeah, you can fix these things. So pretty happy with that, but shame it didn't work. Maybe I can have another look at the Scopemeter, but yeah, I'm going to call it quits for this video and call that one a win. Awesome. So if you want to discuss it, jump on over to the EEVblog forum, links down below, and leave YouTube comments and blog comments and all that sort of jazz. Hope you enjoyed it. Catch you next time.